Conversations That Matter is a partner program of the Center for Dialogue at Simon Fraser University. The production of this program is made possible thanks to the support of the following and viewers like you. Interesting topic, especially when we take a look at CO2 concentration in the atmosphere. Who's our guest today?
Stu, today we have Adrian Corless. He's the head of a company called Carbon Engineering. His background is in alternative fuel sources. You know, here in Canada, 25% of our greenhouse gas emissions come from transportation. And what Adrian and his colleagues are trying to figure out is a way to actually use carbon dioxide as a fuel source. And
like carbon from the air.
That's right, pulling in with huge fans, essentially, air, and taking the carbon out of it and running it through a very sophisticated process that he explains, and then turning it into what is essentially a clean fuel source. And it's very early stages, but it has a lot of activity that's associated here in British Columbia and across Canada, and has great potential. He talks about in his conversation, we've figured out how to do the easy stuff, planting trees, if you will. This is what he calls the deep stuff, the complicated stuff. We've put so much carbon into the atmosphere. How can we turn the whole paradigm on its head, suck that carbon out, and then use it to fuel everything that has essentially been piping carbon, bad kind of carbon, out into the environment for centuries?
The other interesting point that he makes is that if we do this, then we start to reduce the amount of new carbon that gets introduced into the atmosphere, because we stop pulling it out of the ground if we're pulling it from the air.
Yeah, that's right. And that's where really this is, to use a phrase that gets used a lot, a game changer. But if we think about the desire, certainly in the Western world and in developed nations, to get off of fossil fuels, this type of technology, forward thinking, is really going to be critical to achieving a greener future for all of us.
I think it's one of the components that allows us to get from where we are to the world that we say that we want. The catch, of course, is the cost.
The cost, and of course, as we come back to a lot with these conversations, the political will. We have great minds. We're learning through these conversations that here in Canada, we have great minds that are coming up with amazing technologies and solutions. They can't do it alone. They need support. And do we have the political will and the will as a society to invest in and really understand and support these types of technologies?
This is a fascinating conversation. Thank you for joining me.
My pleasure.
I think that this is a fascinating time as we now are starting to move towards what does the future that we want to have look like, and how do we get there? Tell me a little bit about what carbon engineering is about. What is it that you're attempting to do?
So Carbon Engineering, first and foremost, is a technology development company, and we've started from a premise that carbon, first of all, addressing global carbon is necessary, and that it's more complicated than just targeting the easy stuff first. So there's certainly a lot of work that people are doing on targeting carbon emissions from point sources, power plants, et cetera. But we're really thinking that, again, to solve the problem, you need to go much deeper. You need to address the dispersed sources, and primarily you need to address transportation. So carbon engineering is about developing technology to address the carbon footprint of transportation.
But basically you're saying, let's take carbon out of the air and convert it back into fuel. Do I have that right?
That's right. The premise is actually very simple. So the technology we've developed is really about taking CO2 that's already been released into the atmosphere and capturing it, concentrating it, and then using it as a feedstock. In our opinion, the most important thing is to make new fuels out of that and really close the carbon cycle around transportation fuels.
So somebody's going to be looking at you going to say, what? You're going to take the carbon out of the air and you're going to turn it back into a fuel. How do you do that?
And yeah, again, it's a lot of people think that we're trying to propose a perpetual motion machine or something of the likes, but it's actually not that complicated. So, really what we're doing is taking what, produced fuels in the past and just doing it in a mechanized way. So, the carbon itself is really just a carrier for energy. And so ultimately, if we're producing synthetic fuels using atmospheric carbon as a feedstock, we also need a source of energy. And for us, that means primarily some source of renewable hydrogen. So with that combination of atmospheric CO2, which is really what we've developed, and I think which is really the game changer in terms of being able to accomplish this. Taking that in conjunction with the advances that are being made on renewables to produce a renewable source of hydrogen is really now opening up the possibility to do this in a way which is both technically feasible, but now starting to enter into the realm of economically feasible as well.
It seems incredible to me because there's carbon in the space between you and I right now. I can't see it. It's microscopic in size. How do you go about capturing that?
What we're doing is we have a chemical process which takes a lot of atmospheric CO2, large volumes, and puts it in contact with a capture fluid, which is not terribly exotic. It's a hydroxide solution that has affinity for CO2, and through a series of steps, we take that captured CO2, we precipitate it out as a solid, and then ultimately we heat that solid up in a high temperature device, and that process liberates the CO2 in a pure form and allows us to then take those residual chemicals and put them back into our capture fluid. So it's a closed chemical loop process.
Do you have like a big fan or something that sucks the air in, and then what does it do?
What we're doing is we're bringing large volumes of air, driven by a fan through a packed bed which is wetted with our capture fluid. So it's not terrible, again, that front end is not terribly complicated, and it's really just based on industrial pieces of equipment that we borrowed from other industries that we've actually built a novel process around which accomplishes something much, in our opinion, much more important. So.
Okay, so you draw the air in, you extract the carbon out of the air. How much carbon are you able to pull out?
Well, if we're taking 400 parts per million, which is where we're at today in the atmosphere, we typically will pull about 3/4 of that out. And for us, there's no penalty for not taking it all out. That's not our job. Our job is just to take as much as we can out as economically as possible. So we pull about 3/4 of the CO2 out. So our exhaust stream has about 100 ppms of CO2 in it, and that really it's just an optimization at that point about really what's the cheapest way to bring a ton of CO2 out of the atmosphere and make it ready for use as a feedstock.
I can hear people right now saying, well, why not just plant trees? But there's challenges around doing that, aren't there?
I think that works if you wouldn't have done what you've done over the last 150 years. The problem is that we've pulled massive amounts of carbon from not the surface, not from trees. We pulled that carbon from underground sources, from fossil sources, and that atmosphere, or that CO2 is now resident in the atmosphere. So no amount of trees is going to undo what we've done over the last 150 years in terms of the consumption of fossil fuels, and really and using it as a once through process where we've taken that carbon, we put it in the atmosphere, and there really is going to take some time period much longer than probably when humans will be around to get that back underground. So trees are a temporal source to store carbon, but they're not going to solve that problem. Well, if you were thinking about it in terms of fuels production, which is biofuels, then I think that you're going to quickly run into problems if you're thinking about global deployment. So if we think about deploying agricultural or whether it's wood or other waste materials, but ultimately a biological source to be the carbon source for fuels, you quickly are going to realize you're going to have to just do that. There's not going to be room on the planet left to grow food. So it's really just not a scalable option. Now, I think to put it in comparison, what we're doing is really a mechanized way to take CO2 from the atmosphere, to take renewable energy from example from the sun, and really do what biology or nature does, but we can do it in about 1/1000th of the footprint. So for us, it's pretty easy to demonstrate how this can actually be globally deployed and actually be deployed at a scale which solves the complete problem.
I just got to get you to hang on for just 1 second. We'll get back to this in a moment, but I got to take a break right at the moment. We'll be right back. Conversations That Matter is a not-for-profit program made possible thanks to the charitable support of the following and from viewers like you. Please visit conversationsthatmatter.tv and help us to continue to produce this program. Thank you. So where are we at? You've developed this. You know it works. You can turn the carbon into a fuel. How close are we to seeing this deploy on a big enough scale that's going to start to make a difference?
Okay, well, so I'll correct you here a little bit. Is that I wish we were that far along today, but what we have done,
it's wishful thinking on my behalf.
Well, no, but I think it's actually we're not that far off. So what we've done so far is we've developed this technology. We've demonstrated it in pieces over the years. We're currently in the commissioning of a plant up in Squamish, British Columbia, where that particular plant is capturing atmospheric CO2. It's been doing it since May, and concentrating it and producing a pure stream of CO2. So that's what we've accomplished so far, and that's been done with the support of our investors and a number of Canadian funding sources, as well as some Alberta sources, actually. And what we're doing right now is we're just in the formative stages of putting together a consortium of funders and technical partners to do that next thing, which is to take that atmospheric CO2 now as a feedstock for what we'll do next, which is to synthesize fuels. And so out in Squamish, the goal is to take what we're capturing, which is 1 or 2 tons a day. So on a global scale, still small, but that's enough carbon to produce somewhere of the order of 500 liters a day of fuel. So by doing that, and that's what we'll be doing over the next 18 months or so, that's going to really be the first global demonstration of any reasonable scale of this air to fuels concept, which is that closed carbon loop. And I think that's what, again, people are getting very excited about. And that's been something that is a fairly new to our repertoire of things we're working on.
You're still at proof of concept stage, but are you already starting to get interest from industry, from governments, from different areas saying, okay, what's it going to take for us to make this happen?
Yeah, no, absolutely. And I think that we've for a series of I think fortunate coincidences ended up doing our first project here in British Columbia, in particular in Squamish. And so what I'm finding anyway is that in BC right now there's I think a desire to start thinking about what we're going to do, and taking some bold steps to think about how we're actually going to close the gap in terms of our longer-term longer-term targets on carbon. And so, I know right now the province is in the middle of going and developing their climate leadership plan and all the things that will mean. But the feedback we're getting is that it's the right piece of technology, it's the right time, it's the right place, and it solves the right problem. So, we're certainly getting a lot of interest and growing support within the province, and the support we've always had at the federal level, or always meaning the last few years, is continuing to grow as well too. So I think, again, in terms of being able to get support to fund that from continued funding from the Canadian sources, for sure. The support of our existing investor base to continue to participate is there. I'm very fortunate to have an investor base which has I think the vision and desire to go and continue on this process until it's done. So I think that's something, again, that's quite unique and fortunate for carbon engineering.
And so what are the hurdles that you have to clear at this point to be able to introduce this and say, here is one of the solutions that we need to have that will address so many of the concerns that people around the world have? How do we get from here to there?
Yeah, well,
from your perspective.
There's, I would say on the technology side, I think is just the financial support to get to that next step, so we can, I think, have something that's tangible that people can see beyond that it's not really a perpetual motion machine. It's not it's not science fiction. It's just good engineering, and it's a practical approach to solving a problem. So I think getting through the next year and a half and having the support and the funding to continue as it has, I think that's the first thing. And I think the next is that you really need to then have an environment where the policy recognizes the inherent value of a fuel which is net zero carbon, and starts to put in place mechanisms to support the adoption of that fuel. So
what kind of mechanisms would those be?
I mean, at the end of the day, it could be something like, for example, looking at the taxation approach on synthetic fuels and treating it differently than fuels that were fossil based. So I think in BC, or particularly in Europe, for example, there's quite a significant portion of fuel costs at the pump which are tax based on whether it's road taxes or carbon taxes, et cetera. But I think there's policy tools you can use that would, I think, immediately close the price gap between the two and incent consumers to start to make the right decision. And I think ultimately that's sort of taking the edge off the decision-making process of the average consumer. And I think, I'd like to think that voluntarily people would say, paying an extra 25 or 30 cents a liter voluntarily just because it's the right thing to do, that would just be an obvious choice that they would make. But I think that's not likely going to be the outcome beyond a few early adopters.
I wish that we could go straight through, but unfortunately I got to
take a second break here. We'll be right back just after this.
Conversations That Matter is a not-for-profit program made possible thanks to the charitable support of the following and from viewers like you. Please visit conversationsthatmatter.tv and help us to continue to produce this program. Thank you.
So you will need government support because the cost of producing fuel like this is higher than the current method that we're so addicted to.
Yeah, I think the answer is yes. I mean, I think if you believe that you're going to go and use technology to solve energy and climate problems, and you're going to be able to do that in a way that's cheaper and better than what you're doing today in terms of just mining fossil fuels out of the ground, burning them and leaving the CO2 in the atmosphere, that's just not going to happen. And I think, and that's an issue that I think we do face from time to time, because people who invest in technology or people who view technology as always something that's going to provide something that's better and cheaper, and it's going to solve problems that are basically taking the problem away from the consumer. And I think that my opinion anyway is that solving the climate problems aren't going to be quite that easy. I think there's going to be a requirement that the average individual is going to have to recognize that they had a free ride for a long time. Going forward, there is going to be a price to pay to actually deal with the impacts of the things that you're consuming.
So is it a little bit of a challenge for governments? You take a look at smokers, for instance. They pay an inordinate amount of tax, and governments get used to getting that money. The oil companies pay an inordinate amount in royalties and taxes. Governments get used to having that kind of money. If you come along and say, well, you're not going to get that same money from me, and I need you to give the consumer a tax break when they go to use the fuel, are you fearful that you'll bump into some resistance there?
That's a good point. And I think maybe what I would distinguish is how you enter the market, and then ultimately, I think, push that burden back to the consumer, right? I think that, I think the point is that I think that you're going to have to incent the adoption of these technologies in some way at the beginning. And I think that, the idea of using taxation as a tool is one of those. I mean, I think, the idea also that, that there could be, there could be other regulations that require over time, the open market to decide the most cost-effective way to reduce carbon over time. And that's what they do in California. In fact, that's what they do here in BC as well. And then basically send the market signal out saying that the cost of doing that over time is going to increase. Or for example, I don't care how you do that. It's just that every year you're going to reduce the carbon intensity of the fuel mix in the province by 1 to 2%. And ultimately, the cost of sticking with the current fuels will become prohibitively expensive, and over time, the inherent price of carbon is going to go up to a point where synthetics start to make sense. So I think, there's other mechanisms that start to play out more effectively in the long term. But I think I think doing some very concrete, specific things that are, kind of big carrot, small stick kind of things, like putting some very specific incentives in place to send a signal of the importance of some of these technologies up front is not a bad thing.
So getting from where we are to where we want to be, and I see what you're doing as being part of that solution and fundamental. It's not an easy process though, is it? It's not like there's so many different components that are involved. As you look to the future, how long do you think it's going to take for us to be able to find our way down that winding road so that you've got a viable alternative that we can all look to and say, wow, look at what we've done?
Wow, that is a good question. If you asked me a year ago, I think I would have been a bit more pessimistic, and I think that.
Oh, really?
Only because I have seen, I think sort of a growth in understanding and acceptance of the importance of dealing with climate and carbon in particular in the last 12 months. That it really is a different dialogue than it was a year ago. And what I'd like to think is that if we can actually put the technology on the table, we can show that it may not be as cheap as burning fossil fuels, but it's actually pretty competitive. And our view is that by 2020, with where everyone sees and expects solar to be at industrial scale, we think somewhere in the order of about $1.20 a liter to produce synthetics, and that's a production cost. It's not a pump price, but we're not talking $5 or $6 a liter. We're not talking about something which is going to dramatically undo the transportation economy, for example. I think if you can demonstrate the viability of doing that, I think that you could quickly find yourself reaching a tipping point where it just becomes the desirable and right thing to do. And if if policies come in place where the differential between the prices at the pump for the two options of fossil or non-fossil are closed, I don't see any reason again why this can't be deployed, sort of 2020 scale or 2020 timeframe in the scale that it actually starts to have global impact.
On our final break, if you can hang on just a moment, we'll get back to this and just wrap up our conversation in a couple minutes. We'll be right back.
Conversations That Matter is a not-for-profit program made possible thanks to the charitable support of the following and from viewers like you. Please visit conversationsthatmatter.tv and help us to continue to produce this program.
I think the most important thing when I look at it, I say, okay, well, what's the world that we want to live in? And if everybody's saying we need to reduce parts per million of carbon molecules in the atmosphere, this is a way of, yes, supplementing fuel, but more importantly, removing carbon from the atmosphere that's there.
Yeah, and I think that there's looking at it sort of from just this is something that people generally don't, I think, understand fully, is that we're sitting at 400 ppms today in the atmosphere, and there's
and growing,
and there's climate models that say we've got a certain amount of budget left, and when we hit that budget, we can't be putting any more in, and then there's this there's a lot of people who say, well, it's unlikely we're going to actually stop and get to zero net carbon, being emitted into the atmosphere, and we're going to overshoot that number. So, where I see our technology playing a role is that we have a big part to play in helping get to that net zero. So first of all, it's just stopping to put more in the atmosphere, and that's I think where the fuels come into play. Is that it gives you some tools that again lets you drive a growing economy and lets you have transportation as being an important part of that. But you start again to get where you're the 30 megatons a year the 10 to 15 gigatons a year that are attributed to transportation. You can drive that part to zero, and then you can drive other parts of the emissions to zero by dealing with point source capture or introduction of other renewables. But the first thing you need to do is you need to get to zero before you can actually start going the other way, and that's a big challenge. And the technology we're developing has that other potential, which is you can think about also just simply capturing CO2 and pumping it underground and actually starting to remediate the problem. And we haven't talked about that today, and that's something I think that is been recognized by the IPCC committees and the National Academy of Science in the US have both said that we're going to overshoot, and you better start developing pieces of technology that are going to be carbon negative in nature. And certainly, again, we have that in kind of it underpins what we do. But again, and we're a small startup company, and I think that I hope I really truly hope that the technology ultimately help solve that problem, but I think it's going to take a while before there's a sort of a global consensus to start to actually spend money on that exercise.
You talk about being a small startup Canadian company, and this is a global situation, a global crisis that needs to be addressed. Let's say you go through all this proof of concept and you go, okay, now we go, and we're trying to hit certain targets and you're going to play an important role. How are you going to be able to scale up to what the demand might be?
Yeah, and I think that will be, I hope we continue to play a part in that. I mean, obviously, I'm not going to say that I think we're going to be a global fuel provider as Carbon Engineering. I think we'll be, my goal is to grow as an engineering and technology company. But I think, something like this is something that's going to require, companies that have the capital wherewithal, and I think the ability to deploy at a much more rapid scale and larger scale. So I think that being realistic, that our role is really around technology development, and I hope that we'll financially benefit from the deployment of this in a large scale all over the world. But I think our next thing will be to make it better and to think about other ways to provide solutions. That's Carbon Engineering's mandate.
And then probably market it out to others who can then build the structures.
Absolutely. Yeah. Of course. I mean, I think we manage the development and the construction and the operation of things at small scale, and we might do it at medium scale to show that we can move it towards that commercial realm. But I think at that point, I see us looking for partners who are going to help us take it and make this something which is relevant at a global scale.
Well, it's a good fit for the energy sector as it is.
Yeah.
It could be, and they have that capacity.
They do. I mean, I would say right now they're not quite ready to admit they have a problem yet. I mean, that's I mean, this is carbon engineering. I'm coming from with a head office in Calgary. I mean, it's an interesting it's an interesting environment there, which is quite different than British Columbia. And I think again the goal right now within the oil industry, as far as I can tell, is just to continue to look inward and say how do they actually just continue to improve their internal processes, et cetera. So I think that's that's a question about whether or not they'll recognize that this is something which is again their next play, or whether or not someone else will. I don't know.
Well, I think that it's fundamentally important and it's a growing chorus of voices that are saying we want a different world. We don't want to be so reliant on carbon fuels, and we want to address the situation as it continues to grow. And as you pointed out, we'll soar past those IPCC benchmarks. We need to get behind people like you who are, as in the words of Bill Gates, using science to address the challenges of the world. So I wish you all the best of luck, and thank you for coming in and doing
Thanks
this.
very much.
Thank
I appreciate the time. Thanks.
Thank you.